Today we will talk about section 11.5 on the finances involved with home ownership. First, let's talk about some initial expenses when you're thinking about or beginning to buy a home. When you purchase a home, you generally make a down payment and finance the remainder of the purchase price with a loan obtained through a bank or a savings and loan association. The amount of down payment can vary, but it's normally between 10 and 30% of the selling price. The mortgage is the amount that is borrowed to buy the real estate. The amount of the mortgage is the difference between the selling price and the down payment. So to calculate the mortgage, you take the selling price, remove any amount of down payment that you made, and what's left is the mortgage amount. The down payment is generally the largest initial expense in purchasing a home, but there are other expenses associated with the purchase. These payments are due at the closing when the house is finalized for sale, and they're called closing costs. The bank may charge fees for attorneys, credit reports, loan processing, and title searches. There may also be a loan origination fee. This fee is usually expressed in points. But 1 point is just 1% of the mortgage. You can think of the word point as just being percent. Let's do an example involving down payments and closing costs. Suppose the purchase price of a home is $392,000. A down payment of 20% is made. The bank charges $450 in fees plus 2.5 points. Find the total of the down payment and the closing costs. So remember, the down payment is the amount you give up front. It's 20%, so you take 20% of $392,000. 20% is 0.20. When you multiply, you'll find out that the down payment is $78,400. We want to find the down payments and the closing cost. Let's move on to the closing cost by looking at the mortgage amount. The mortgage amount is the selling price minus the down payment. Why do we need the mortgage amount first? Because the closing costs are based on the mortgage amount. So even though they didn't ask for the mortgage amount, we can't find the closing costs without getting the mortgage amount. The selling price is $392,000. We subtract away the down payment and we find out that the mortgage amount is $313,600. That $313,600 is what the closing costs are based on. And remember, a point just means percent. So we need to take 2.5% of $313,600. 2.5 is 2.5. And if you take 2.5% and change to a decimal, you get 0.025. Multiplying by $313,600, you find the points are $7,840. The only other closing cost mentioned in the problem is the $450 in fees. So the closing costs are the fees plus the points. If you add those two numbers together and then throw in the down payment, adding those numbers together, you get $86,690. So the problem asks for the total of the down payment and the closing cost. We found in the first calculation that the down payment was $78,400. Then we had to calculate the mortgage amount in order to figure the closing cost. The mortgage amount turned out to be $313,600. And then points were 2.5%. So we got 2.5% of the mortgage amount, which came out to be $7,840. And then those fees of $450 were thrown in on top. So the total of the down payment and the closing cost was $78,400, which is the down payment, plus the $7,840, which are the points, and the $450, which were the fees. And if you add all three of those numbers, which is what the problem asks us to do, you get $86,690. Let's talk a little bit more about mortgage. If a bank gives you a mortgage, you're agreeing to pay off the loan in monthly payments. If you fail to make the payments, the bank has the right to foreclose, which means that the bank takes possession of the property and has the right to sell it. There are many types of mortgages, so a lot of terms will differ, and sometimes considerably. Some mortgages are adjustable rate mortgages, sometimes called ARMs or ARMs. ARM interest rates are adjusted periodically to closely reflect the current interest rates. In other words, once you sign for a certain rate, it might change based on what's going on in the economy. The mortgage agreement specifies exactly how that interest rate can change. But there are also fixed rate mortgages, or more commonly called conventional mortgages, where both the interest rate and the monthly payment is fixed and it stays the same throughout the whole term of the mortgage. The term of a mortgage can vary. Terms of 15 years, 20 years, 25 years, 30 years are the most common. The monthly payment on a mortgage is called the mortgage payment. The amount of the mortgage payment depends on the size of the mortgage, the interest rate, and the term of that loan. The length of the loan is also called the term of the loan. Here's the actual formula you use to calculate monthly payments. That PMT stands for the monthly payment, and it's equal to capital A, which is the amount of the mortgage, times that entire complex fraction. The numerator of that complex fraction is R over N, where R is the annual interest rate and N is the number of payments per year. And since these are all going to be monthly payments, N will always be 12 for us. And the denominator of that complex fraction is 1 minus another expression, which is 1 plus that same R over N that you see in the numerator, and that entire sum is raised to the negative NT power. That formula will be given to you. You don't have to memorize it, but you will need to know what each letter stands for because that information will not be given to you. So let's do an example using that formula, and let's actually calculate a mortgage payment. Suppose Allison buys a condo, and with a loan of $134,000 for 30 years and an annual interest rate of 6.5%, she wants to know what her monthly mortgage payment will be. We'll just use the formula. The main thing here is being careful, getting the right values into the formula, and then being careful with your calculator. Capital A here is the $134,000. That's the amount of the mortgage. Little r is the annual interest rate. 6.5% is 0.065 as a decimal. N is the number of payments per year, and for us it will always be monthly payments, so N will be 12 consistently here. And the only other thing is the T, and T is the number of years or the term of the loan. It's 30 years, so T is equal to 30. I won't go through this in such detail in the rest of the calculations, but here I'm going to take it one step at a time, and after that you have to practice and learn to do this yourself. If you can't successfully do this, all the other things are going to be for nothing because you're going to miss the answer. So even if you plug everything in right, if you can't practice to the point that you can get the answer with the calculator, then you're going to get the wrong answer. So this is extremely important. I'm going to go through this carefully one time, and then I want you to practice. So the first thing you want to do, as we said earlier, is put parentheses around the entire numerator and entire denominator when you see a complex fraction. So before you even get started with punching numbers into the calculator, if you have a complex fraction, always put parentheses around the entire numerator and the entire denominator. Now we're ready to do it. So here are the keystrokes. You key in 134,000. Notice that 134,000 is sitting right beside that bracket. That's an implied multiplication. So when you see that, you might even just write in a multiplication symbol there just so you don't forget to type it in. But you have to type in the multiplication symbol into your calculator, even though it's actually not in the formula. It's an implied multiplication. Then you go left to right. You've got that bracket. The bracket is just another way of writing a parenthesis so that it stands out a little more, but it's a left paren. Then you move into the numerator, and what you see is another left paren. So you type that in. Then you type in the 0.065. You really don't have to type in that leading zero. Then the division symbol. So you press the division key. Then you enter 12. Keep moving left to right. You come to a right paren. Now you're ready to go into the denominator. Remember, the fraction bar symbol itself is a division symbol. So before you jump from the numerator to denominator, you have to press divided by. Now you move into the denominator. The first thing you see is a left paren. Then you've got 1 minus. Now you have another left paren. Then you have 1 plus. Then you have the 0.065 divided by, enter 12. Then you see a right paren. Now you've got an exponent. Before you start typing in the exponent, you have to tell the calculator that you're about to type in an exponent, and you do that with the X to the Y key. So now the calculator expects you to type in the exponent. Notice that the exponent is a negative number. As we've talked about earlier, you cannot enter a negative number directly. You have to type in the positive value, the 360, and then press the plus minus key. That's how you enter a negative number. Keep moving from left to right. The next thing you see is a right paren, and now you're done with the entire denominator, so that pushes you to the final right paren. Remember, the brace is just a more emphatic way of writing the parenthesis. It just shows you the match is better. And now that you're done, you press equal to evaluate the expression. And if you've done all of that correctly, you'll find that the monthly payment is $846.97. Now, I can't do this for you. You have to practice this. Watching me do it is not enough. Practice it on your own. In fact, you can pause the video right now and practice this and keep doing it until you can reliably do it without making mistakes. Also look and see if the answer even seems reasonable. If you got an answer of like $10,000 a month on a regular house loan, in fact it's just a $134,000 condo spread over 30 years, that doesn't seem reasonable. Or if you get $8.50, you know that doesn't seem reasonable. That's not nearly enough. At least glance at your final answer to see if it seems way out of range of what you expected it to be. I can ask other questions once I know what the monthly payment is. For instance, I could also ask, what is the total of all the payments over the life of the loan? In other words, if Allison pays the bank $846.97 every month for 30 years, what is the total that she's paid the bank over the life of that loan? Well, once you understand what the question's asking, it's fairly easy. There are 12 monthly payments for 30 years, so you've got the monthly payment of $846.97 times 12 times 30. 12 months a year for 30 years. And if you multiply those together, you'll find out that on that $134,000 condo, she paid the bank back over the course of 30 years $304,909.20, maybe 2.5 times what she actually borrowed. I could ask what the amount of interest paid is over the course of the loan, that 30 years. Once you've done all these calculations, I think you can see how easy that is. In fact, I sort of alluded to it. It's the difference between what she paid the bank over the 30 years and what she actually borrowed. So that $304,909.20 minus the initial loan of $134,000, that is actually the amount of interest Allison paid to the bank over 30 years. So she paid the bank more in interest than the value of the initial loan. The initial loan was $134,000. She actually paid the bank back over 30 years $170,909.20. Or if it's in the future, she will have paid the bank that amount. A portion of a mortgage payment pays the current interest owed on the loan, and the remaining portion of the mortgage is used to reduce the principal owed on the loan. When you're making a monthly payment for a mortgage, part of that monthly payment is essentially the bank's profit. They charge you to make a profit for loaning you that money, and the rest of that monthly payment goes to lower how much you owe the bank. So when you pay the bank $1,000, it doesn't lower the amount of the loan by $1,000 because the bank takes its cut of the profit and reduces the principal by the rest. So you have to keep that in mind. This process of paying off the principal and interest, and it's just a same as a car payment when you take out a car loan, except you're usually borrowing a lot more money when you're doing a house. It's called amortizing the loan. The interest payment, principal payment, and balance on the loan can be calculated for all of the mortgage payments throughout the life of the loan. If it's a 30-year loan, that would be 360 of them. Or a computer can be programmed to make these calculations and print out the information. Such a printout is called an amortization schedule. It lists for each mortgage payment the payment number, the interest payment, the amount applied toward the principal, and the resulting balance to be paid. So let's do an example of calculating the principal and interest on a mortgage. Suppose you purchase a condominium for $98,750 and obtain a 30-year fixed-rate mortgage at 7.25%. After paying a down payment of 20%, how much of the first payment is interest and how much is applied toward the principal? First of all, we need to find that down payment because the down payment comes off of the amount you're going to borrow. So the mortgage amount does not include the down payment, so you have to get rid of that down payment. So we know the condo was purchased for $98,750. We also know that this person made a down payment of 20%. So the down payment is 20% of the purchase price. $98,750 times 0.20 is $19,750. So the down payment is $19,750. Now we need to find the mortgage amount, and that's just the difference between the purchase price of the condo and how much you paid down. So $98,750 minus $19,750 is $79,000. So this person actually borrowed $79,000 even though the condo was worth more. Now we're ready to find the monthly payment using the formula that we've been using. Plug in all the numbers. The mortgage amount is the $79,000. The interest rate is 7.25%, which is 0.0725. These are all monthly payments, so N is going to be 12. This is a 30-year fixed rate mortgage, so T is 30. Now it becomes a calculator problem. I'm not going through this step by step as I did before. If you're still having trouble with that sort of thing, go back to the previous example where I went step by step and practice it, and then come back to here. But when you do this, you still need to go in and put parentheses around the entire numerator and entire denominator. And there are your keystrokes. If you go through this and get the correct answer, you're good. If you didn't, you need to go back to the previous problem where I did it step by step and sort of step through it and then come back to this. And you need to practice this until you can get the answer of $538.92. The mortgage payment each month is $538.92. Now the question actually asked how much of the first payment is interest and how much is applied toward the principal. We only got the monthly payment because you can't answer that question until you know the monthly payment. So this monthly payment of $538.92 is going to be split into two pieces. The first piece is how much the bank takes out as profit, and that's calculated by looking at the interest rate. And then whatever's left goes to reduce the principal. So let's do this. The simple interest formula on the first month's payment tells you the answer to the question about how much profit the bank will make. In other words, how much interest is charged by the bank. I equal PRT is the simple interest rate. The principal is the $79,000 you start off owing. The interest rate is 7.25%, which is 0.0725. And T is the time, but remember the time always has to be given in years. A month is 1/12 of a year. Your keystrokes would be 79,000 times 0.0725 divided by 12. You come up with the interest being $477.29. That's sort of shocking. Out of the first payment of $538.92, over $475 of it is just interest, which is the profit to the bank. You're hardly reducing your principal at all. It sort of shocks people to see that for the first time. Finally, we want to find the amount of the first payment applied to principal. Well, it's just the rest. Whatever's left over after you take that $538.92 and pay the bank its interest due, which is $477.29, you've only reduced your principal by $61.63. So in the first few years of paying off a mortgage, you're not reducing the principal very much. It takes several years to make a significant dent in the amount you owe the bank. It's a little shocking when you first see it. When a home is sold before the term of the loan has expired, the owner must pay the lender the remaining loan balance. To calculate that balance, we can use the APR Loan Payoff formula. In other words, sometimes you don't keep the home through the whole 30 years or however much you took out the loan for, the mortgage for, so you need to pay off what you owe if you sell that house early. Here's the formula. So when you get ready to sell the house, you need to look at how many payments you have yet to make and plug that as the capital U into this formula. And if you calculate using this formula, you get the amount you have to pay off. Notice it's very similar to the last formula, except that capital U is in there because it represents the number of remaining payments. And we've taken the equation, instead of it being payment equal to, now it's capital A equal to. The payment is known, and we're trying to figure out how much is left to be paid back to the bank. So in the previous problem, we were solving for payment, monthly payment, the PMT. In a problem where you're doing a payoff, an early payoff, you're going to be solving for A, and you need to know that capital U, which is how many payments you have left before you're done. But given that information, you use this formula. Let's do an example of paying off a mortgage early. Suppose Ann's monthly mortgage payment is $645.32 on a 30-year loan at an annual interest rate of 7.2%. After making payments for 5 years, she decides to sell the house. What is the mortgage payoff? Well, again, if you know what the variables are and are careful, what really takes the concentration is using the calculator correctly. So we need to get the formula and notice that that capital U is the amount of payments yet to be made. The problem says that she wanted to sell this house after 5 years. Well, it's a 30-year mortgage, so she's got 25 years of monthly payments remaining. Well, 25 times 12 is 300, so that means that capital U is 300. Capital U is the number of monthly payments left. That tells you that capital U is 300. The payment was given, the monthly payment is $645.32, so that's the PMT. The interest rate is 7.2%, which is 0.072 as a decimal, and it's compounded monthly. All these problems will be monthly, so that will be 12. Plug those numbers in and then be very careful. Now, the calculations aren't exactly the same as for the previous problems, but there are no new buttons that you have to press. You may have to press them in slightly different order. And don't forget to put parentheses around the entire numerator and the entire denominator. I'm not going to show this step by step, but you're going to do the same presses as you did before, maybe in a slightly different order, but practice makes perfect. Here's what you should get for your keystrokes, and if you did it correctly, you're going to get $89,679.01. So if Ann wants to sell that house after 5 years, she's going to have to pay off the mortgage by giving the bank $89,679.01. Let's talk a little bit about ongoing expenses. In other words, once you've bought the house, you still have expenses. Besides a mortgage payment, there are other ongoing expenses. Among these are cost of insurance, property tax, utilities, your heat, electricity, and water. City or county services such as schools, recreational and maintenance services, police and fire protection are financed quite often by the revenue from taxes levied on real property or property taxes. So when you're actually paying your mortgage, you also have to look at where you live, because some of these local governments will add taxes to finance these schools and recreational services, your fire and police protection. So that also is going to factor in on how expensive it is to own a home. Property tax is an annual expense that can be paid monthly, quarterly, semi-annually, or annually. Homeowners with a mortgage must have fire insurance so that lenders can be repaid if it burns down. If that house burns down, the lender will be stuck unless you have insured it, so you're going to be required to have that fire insurance. Let's do an example. Suppose John's monthly mortgage payment is $1,145.60, and he has an annual property tax bill of $1,074. He also has an annual fire insurance premium of $600. Find the total monthly payment for the mortgage, property tax, and fire insurance. In other words, put it all into one sum. So the monthly property tax bill is the annual rate divided by 12, because we were told that the annual property tax was $1,074, but we're looking at monthly payments, so we have to divide it by 12. So if you take $1,074 and divide by 12, you find out that the monthly property tax bill is $89.50. The fire insurance bill is the same way. We were told that the annual fire insurance premium is $600, so if you want to see how much that is each month, you have to divide by 12. So $600 divided by 12 is $50. So the monthly payment is going to be the mortgage payment, which was given to be $1,145.60, plus the monthly property tax bill, which we calculated to be $89.50, plus the monthly fire insurance bill, which we calculated to be $50. And if you add those three together, you get $1,285.10. So although your mortgage payment is under $1,200 a month, by the time you factor in this other stuff, it's closer to $1,300 by the time it's all said and done. How about this one? What do you want to calculate the most we can afford to buy? If we're out shopping for a house, it'd be nice to know what price range you can look in. And this is an example of that. You have saved $18,000 for a down payment on a house. Your bank requires a minimum down payment of 17%. They're going to require you to make at least a 17% down payment. What is the maximum price you can offer for a home in order to have enough money for the down payment, and then round your final answer to 2 decimal places? Well, this is going to require a little bit of algebra, so let's call X the price of the house, because that's what we're looking for. How expensive a house can you actually afford? The bank is going to require you to make a down payment of 17%, so if you can't come up with that 17% down payment, you can't buy that house. It says you saved $18,000, so that means that $18,000 has got to be 17% of the price of the house. That gives you a nice little simple equation. 0.17x is equal to 18,000. If you divide both sides by 0.17, you'll find out that the most expensive house you can afford to buy, given that restriction of a 17% down payment, would be $105,882.35 house. So if you're looking at homes, there's no sense in looking at a home any more expensive than that because you couldn't afford to buy it. Keep in mind you're going to be given some of these finance formulas for the test. If you have the PowerPoint, you can click this hyperlink and actually see the list of formulas.